Hi guys, my name is Enes Atlan. I am physics teacher, and today we are going to talking about universal gravitation. All particular bodies experience the force of pulling each other at some distance. This is called gravitation. And objectives in this chapter we will learn how do the bodies interact with each other at some distance, how to determine the mass and size of heavenly bodies, Kepler's laws of planetary motion, and the motion of a satellite and escape speed to launch a rocket into space, why we do not feel the motion of Earth. And you may have heard the legend that Newton was struck on the head by a falling apple while napping under a tree. Newton analyzed astronomical data on the motion of the moon around the Earth. Soon he concluded that the force law governing the motion of planets was the same as the force law that attracted a falling apple to the Earth. Law of universal gravitation states that every particle in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. There's a two mass 1 and mass 2. There's a distance between them is d, and there's a gravitational force F21, F12, and force of 2 on the 1 and force of 1 on the 2, and gravitational force is equal to F12 and F21. But F21 is minus y because direction is opposite. Force is a vector quantity, and in vector quantity positive and negative sign show us direction. And the Fg formula will be minus g times mass 1 times mass 2 over distance square. And g is said to be universal gravitational constant, and this constant is 6.67 times 10 power minus 11 Newton times meter square over kilogram square. And since g is so small number and gravitational force is sensitive for giant masses, like you cannot feel between two people gravitational force. And there are three objects and three planets, Sun, Moon, and Earth. Now we'll find formula between the planets. And Fg1, gravitational constant times mass of the Sun times mass of the Moon over distance square. Fg2, between the Moon and the Earth, Fg2, g times mass of the Earth times mass of the Moon over distance square. Fg3, gravitational constant g times mass of the Sun times mass of the Earth over distance between them square. And don't forget to take distance from the center of body. Example, 10 kg of two masses are at distance of 2 meters. What is the attractive force between them? And formula Fg, g times mass 1 times mass 2 over distance square. G is constant, 6.67 times 10 power minus 11 Newton times meter square over kilogram square, and times mass 1 is 10 kilogram, mass 2 10 kilogram, and distance is 2 square. We'll take, and Fg will be approximately 1.67 times 10 power minus 9 Newton. And the direction of the gravitational force will be each other. Next example. The mass of the Earth is 6 times 10 power 24 kilogram, and the mass of the Moon is 7 times 10 power 22 kilogram. Distance between the Earth and the Moon is 252,000 kilometers. What is the gravitational force between the Moon and the Earth? G is 6.67 times 10 power minus 11. And the gravitational force between the Moon and the Earth, formula, same formula we are using. Fg is g times mass of the Earth times mass of the Moon over distance between them square. G is constant, mass of the Earth and the Moon is given in the question. We'll put in the formula, and R we will convert. R is given in kilometer, but I need to convert kilometer to meter, and 252,000 kilometers is equal to 2.52 times 10 power 8 meter. And Fg will be approximately 11.12 times 10 power 20 Newton. and direction of the gravitation force will be each other. Yes, this next example is your homework, and in this example there are 3 billiard balls and mass 1, mass 2 and mass 3. Masses are same, 0.3 kilogram. These are placed on a table at the corners of the right triangle as shown in the figure. Calculate the gravitational force on the cue ball mass 1 resulting from the other 2 balls. Yes, we need to know resultant force on mass 1. And distance between them is 0.4 meter, 0.5 and 0.3 meter. And see you next lesson. Please solve this example and send me on email. See you next lesson. Thank you for watching.